All right, so basically part 2 is just more applications. So we're going to look at half-lives and doubling times and financial problems that involve exponential models. So basically exponential models have a fixed doubling time and a fixed half-life. What is the doubling time? The doubling time for an exponential growing quantity is just the time it takes for the quantity to double in size. And the half-lives correspondingly is the time it takes for the quantity to become half of the original size. So if you start with 100 bacteria and the doubling time is 2 hours, that means that in 2 hours it grows to 200. It doubles in size. These formulas, the half-life and doubling times, are just specific cases of the previous formula we just did in the previous video. That one was this, right? So to get the formula for half-life and doubling time, we're just going to consider this k to be either the half-life or the doubling time. So if I say that k is the doubling time, what is my formula going to become? So the amount after time t is going to be the amount you start, A0. So the quantity doubles every k unit of time. So what should be b? Well, since it doubles, b should be 2 to the t over k. So in this case, k represents doubling time. So this is just the formula for the doubling time, where k is the doubling time. Now, if k represents half-life, then what should the formula be? At equals a naught, you start, and then what should b be? The decay factor? Well, it's half, because, okay, t over k. So k in this case is half-life. All right, so for example, a radioactive substance has a half-life of 72 years. Well, this means that k is 72 years. It means that every 72 years, the quantity halves in size. Okay, so we're going to use the second formula. If they are initially 3.5 grams, so let me write down the formula first. The amount is what you start with, 1/2 to the t over 72, because my k is 72, because it halves every 72 years. So if there are initially 3.5 grams of the substance, how much will remain after 30 years? So you start with 3.5 and you're interested to see how much is after 30 years. So your time is 30. So the amount after 30 years, that's what this means, right? It's not 8 times 30. It means the amount after 30 years is the initial amount, which is 3.5 grams, times 1/2 to the t, which is 30 in our case, over 72. So when I plug this in the calculator, 3.5, and plugged it in the calculator with t equals 30 and k equals 72, and we get 2.62. 2.62. So the amount after 30 years is 2.62 grams. Make sure you get a number that is less than 3.5, because you start with 3.5 and it decays. Okay, so if you're dealing with doubling time or half-life, that's just a specific case where b is 2 or 1/2, and k represents either the doubling time or either the half-life. You'll practice more in the homework with these types of problems. So the next problems we're going to look at is financial problems. And since we're dealing with money and principles and value of money after 10 years, basically instead of A and A0 is going to represent the principal, the money you start with, or how much you put in an account at the beginning. So the names are going to change now. Instead of a t, I'm going to call that v, and instead of a 0, I'm going to call it p. You'll see it's the same formula, it's just we're giving different names. So the value v of p dollars, the principal, invested at an annual interest rate r, compounded n times a year, is given by this formula. Okay? So the value stands for the amount after time t, and p is the initial amount, the principal. So if you invest $2,500 at 4.25, to construct an equation that describes the value of your investment at year t, if your money is compounded annually means that n times a year, annually means that n equals 1, only once a year, so n is 1. So your formula, v equals p times 1 plus the rate divided by n equals 1 times t. So this is basically the formula. The only thing we change is that we let n equals 1 because it's annually. So therefore the equation is v equals p times 1 plus r to the t. So that's the equation, where p is 2,500, and then 1 plus the rate is 4.25%. We always use it as decimal, so it'll be 0.0425 to the t. All right, now for number 3, construct an equation that describes the value of your investment when it's compounded quarterly. Well, quarterly means how many times a year? What is n? Quarterly means n is 4. So the formula becomes v equals 2,500 times 1 plus the rate, which was 0.0425, divided by n, which is 4, to the power 4 times t. Okay, so the only thing that changed is that n is 4 now. Construct an equation that describes the value of our money if it's compounded monthly. Well, monthly means that n is 12. So then I just changed that n is 12, and that's the formula we're going to use. Now, how much money will your 2,500 be worth after 5 years compounded quarterly? Well, in the quarterly one, this is the formula I'm going to use. So the value of my money is just going to be 2,500 times 1 plus 0.0425 over 4 times to the power 4 times after 5 years. That means that my t is 5, so 4 times 5.